Cumulative distribution function. These are the learning outcomes for this lesson. If x is a continuous random variable with probability density function fx, then the cumulative distribution function is given by capital Fx, where fx equal to probability x less than or equal x. Means summation of probability up to particular value x. Since this is a continuous random variable, we integrate from negative infinity up to x. And this is the graph for cumulative distribution function. Note that probability x less than or equal a denote as fa, and probability x greater or equal x1 less than or equal x2 is fx2 minus fx1, and probability fx equal to differentiate cumulative of fx or f prime x. Example 1. X is a continuous random variable with probability density function fx. X from 1 to 3. Find the cumulative distribution function. Function is from 1 to 3. Means from 1 to 3 function is 1 over 4 times 4 minus x. And for less than 1, this is 0. For greater than 1, this is 0. Means no function. And for cumulative, we have to find function from negative infinity to infinity. Means for this fx, we have 3 intervals. So for first interval, x less than 1, cumulative is from negative infinity to x, where x should be less than 1. Function is 0 dx. So integrate 0, we get 0. So for negative infinity up to start of interval, cumulative is always 0. For next interval, x is from 1 to 3. So interval is from 1 to 3. Cumulative is from previous interval. Highest value is 1, so this is f1 plus 1 up to x. Function is 1 over 4 minus x dx. So substitute 1 into previous interval function, we still get 0 plus, and integrate this, we get 1 over 4x minus x squared over 2 from 1 to x. Substitute, get 1 over 4. Substitute x into x, we still get 4x minus x squared over 2 minus, substitute 1, 4 minus 1 over 2. Simplify, we get 1 over 4x minus x squared over 2 minus 7 over 2 equal to x minus x squared over 8 minus 7 over 8. This is the cumulative for interval 1 to 3. And last interval is for x greater than 3. Cumulative is from previous interval. Highest value is 3. Plus integrate 3 to x. Function is 0 dx. So f3, substitute 3 into function is 3 minus 3 squared over 8 minus 7 over 8. And integrate 0, we'll get 0 equal to 1. And notice that the first interval will always be 0 and the last interval will always be 1. Therefore, cumulative function is 0 for x less than 1. If x minus x squared over 8 minus 7 over 8 for 1 to 3 and 1 for x greater than 3. So this is the cumulative distribution function. Using fx to find probability of x. The cumulative distribution function can be used to find probability as follows. Probability x less than or equal s1 is fx1. Probability x between x1 and x2 is fx2 minus fx1. And notice that if they are equal or not equal, the function is still fx2 minus fx1. So for continuous random variable, the sign equal or do not have equal doesn't matter. We only consider the value x1 and x2. Example 2. The continuous random variable x has cumulative distribution function given by fx. So this is a cumulative distribution function. Find probability x less than or equal 0.5 means from negative infinity up to 0.5. So 0.5 is between 0 and 2 here. So function is 2x over 5. And probability x less than or equal 0.5 means cumulative from negative infinity up to 0.5 is given as f of 0.5. So function is 2x, x is 0.5 over 5 equal to 1 over 5. B x from 1 to 2.5 equal to f of 2.5 minus f1. So 2.5 is between 2 and 3. So function is 4 over 5 plus 2 over 5. 3x is 2.5 minus 2.5 square over 2 minus 4. This is f2.5 minus f1. f1 is between 0 to 2. Function is 2x, x is 1 over 5 equal to 11 over 20. Example 3. The continuous random variable x has the probability density function defined by fx. Find cumulative distribution function fx. So we have intervals 0 to 1, 1 to 2, 2 to 3. Means put into intervals. We get 0 to 1, 1 to 2, 2 to 3. 0 to 1. 0 to 1 function is 1 over 2. 1 to 2 function is negative 1 over 2x plus 1. 2 to 3 function is 1 over 2x minus 1. And 0 otherwise. So the first function is from negative infinity up to infinity. The first function is for x less than 0. So x less than 0 function cumulative is from negative infinity up to x. Function is 0 dx. So integrate 0, we get 0. And then from 0 to 1, function is cumulative from last interval f0 plus integrate from 0 up to x, function is 1 over 2 dx. So substitute 0 into function, we get 0 plus integrate 1 over 2, we get 1 over 2x from 0 to x equal to substitute x, we get 1 over 2x minus 0. So function is 1 over 2x. And next interval is from 1 less than 2. So function equal to cumulative from last interval up to 1 plus 1 to x. Function is negative 1 over 2x plus 1 dx. So f1 substitute into 1 over 2x is 1 over 2 times 1 plus integrate 1 over 2 x squared over 2 plus x from 1 to x. So 1 over 2 plus negative x squared over 4 plus x from 1 to x. 1 over 2 plus, substitute, negative x squared over 4 plus x minus negative 1 over 4 plus 1. Simplify, we get negative x squared over 4 plus x minus 1 over 4. Next interval is from 2 to 3. Cumulative function is f2 plus 2 up to x. Function is 1 over 2x minus 1 dx. So f2, substitute 2 into function, we get negative 2 square over 4 plus 2 minus 1 over 4 plus integrate 1 over 2 x squared over 2 minus x from 2 to x. And this gives us 3 over 4 plus substitute x squared over 4 minus x minus 2 squared over 4 minus 2 equal to x squared over 4 minus x plus 7 over 4. And last interval is x greater than or equal 3. Function is fx equal to f3 plus 3 to x. Function is 0 dx. So f3 is 3 squared over 4 minus 3 plus 7 over 4 plus integration is 0. So equal to 1. Therefore, function is, this is the cumulative distribution function. Hence, determine A probability x less than or equal 1.5. So, probability x less than or equal 1.5 equal to f1.5. So from function, 1.5 is between 1 to 2. So function is negative x squared. X is 1.5 square over 4 plus x minus 1 over 4. So equal to 11 over 16. B, probability x greater than 1.5. So 1.5 is here. We need greater than 1.5. So equal to 1 minus probability less than equal 1.5. We minus the one that not included. So 1 minus probability x less than or equal 1.5 is 11 over 16. So 1 minus 11 over 16 is 5 over 16. C, probability x between 0.5 and 1.5. So f1.5 minus f0.5. f1.5 is 11 over 16 minus f0.5. 0.5 is between 0 to 1. So function is 1 over 2, x is 0.5 equal to 7 over 16. D, probability x greater or equal 0 less than 2.5 equal to f2.5 minus f0. f2.5 is 2.5 square over 4 minus 2.5 plus 7 over 4 minus 0 equal to 13 over 16.